Welcome to the world of serverless architecture. In this video, we're going to explore function as a service and various serverless patterns. Get ready to learn how to build scalable applications without the need to manage servers. Let's dive in. So, what exactly is serverless? Serverless computing is a cloud computing model that allows developers to build and run applications without the burden of managing server infrastructure. This approach comes with key benefits. Firstly, event-driven execution, which means functions only run in response to specific events. Secondly, pay-per-use, so you only pay for the resources you consume during function execution. Thirdly, auto-scaling, which ensures your application automatically scales based on demand. Let's talk about function as a service, also known as FaaS. The core concept here is the ability to execute individual functions in response to events, all without managing server infrastructure. Look at the simple Lambda function example, where we define a function called Lambda handler that processes an incoming event and returns a greeting. This function is triggered by an event, such as an HTTP request, and it automatically scales to handle the incoming traffic. Now, let's explore some of the key serverless providers in the cloud computing landscape. First, we have Amazon Web Services, or AWS, offering Lambda, an event-driven compute service with an extensive ecosystem. Then there is Azure, providing Azure Functions, a serverless compute service with strong enterprise integration. And lastly, Google Cloud, offering Google Cloud Functions, a simple function service with auto-scaling capabilities. Now let's delve into event-driven architecture. In an event-driven architecture, the flow typically starts with an event source such as an HTTP request, a database change, or a file upload. This event triggers a function to execute, which processes the event and performs specific logic. Finally, the function generates a response, which could be returning a result or triggering another action. Keep in mind that functions execute only when triggered by events, making it a highly efficient and scalable approach. Let's explore some common serverless patterns that you can use to build various types of applications. We have the API gateway pattern, where serverless functions back RESTful APIs. There's also the Microservices pattern, where services are decomposed into individual functions. Another pattern is data processing, which involves using serverless functions for extract, transform, load pipelines, and stream processing. Finally, there are scheduled tasks, which enable time-based or event-driven automation. Let's take a closer look at the API gateway pattern. The request flow starts with a client request, which is routed through an API gateway. The API gateway then invokes a Lambda function to process the request. Finally, the Lambda function returns a response back to the client. In this example code, we have a REST API handler called getUsers, which extracts query parameters from the event, fetches users from a database, and returns a JSON response. Let's discuss the benefits of adopting serverless architecture. First and foremost, cost efficiency, as you only pay for the actual execution time and resources used. Another significant advantage is auto-scaling, which automatically scales your application from 0 to thousands of requests, ensuring optimal performance. Serverless also enables faster deployment, allowing you to focus on code rather than infrastructure management. And finally, zero maintenance, as you don't have to worry about server patching, monitoring, or capacity planning. Let's address the limitations and considerations of serverless architecture. One common challenge is cold start latency, which refers to the initial request delay when a function hasn't run recently. There are also execution limits, such as timeout constraints and memory limitations. Another consideration is vendor lock-in, due to platform-specific implementations and dependencies. Lastly, debugging complexity can arise due to limited local testing and distributed tracing challenges. Let's explore some best practices for building serverless applications. A key guideline is to keep functions small and focused, adhering to the single responsibility principle. Design for stateless execution, ensuring each function invocation is independent. Optimize for cold start performance to minimize latency. And implement proper error handling to ensure application reliability. Looking at the optimized function example, we initialize a database client outside the handler to reduce cold start time. The Lambda handler then processes user data, handles success and error responses. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.